I want to ask you something, and I want you to be honest. How does a refrigerator keep things cold? Take a second. Think about it. Most people would say something like, it generates cold air, or it has a cooling system inside. Maybe you'd mention ice, or freezing, or some kind of temperature control. And here's the thing. That answer feels right. It feels completely, totally, obviously right. But it's wrong. Your refrigerator does not make cold. It has never made cold. There is no cold being produced inside that box right now, because cold is not a thing. You cannot make it. You cannot store it. You cannot generate it. Cold is just what's left when heat is gone. And that one shift from the fridge makes cold to the fridge removes heat, that's the whole video. Because once you understand what it means to remove heat, the machine that does it is one of the most satisfying things you will ever learn about. Okay, so if your fridge removes heat, where does the heat go? Pull your fridge away from the wall right now, or just reach behind it. Feel that? It's warm back there. That warmth isn't a side effect. That warmth is the point. That is the heat that used to be inside your food, now sitting in your kitchen. Your fridge is a heat-moving machine. It takes heat from the inside and throws it out the back, over and over, every hour of every day. But how does it move heat? Heat doesn't have legs. You can't just pick it up and carry it somewhere. Here's the trick, and this is the part that genuinely blew my mind the first time I properly understood it. When a liquid turns into a gas, when it evaporates, it doesn't just change shape. It absorbs heat from everything around it. It literally pulls thermal energy out of its surroundings to power that transformation. You felt this. Dab a little alcohol on your skin. The moment it starts evaporating, cold, not because the alcohol is cold, because it's stealing heat from your skin to evaporate. That's the engine inside your refrigerator, a liquid that evaporates, steals heat, and disappears into vapor. The only question is, after it's evaporated, how do you turn it back into a liquid so you can use it again? This is where the engineering becomes beautiful. Inside your fridge is a sealed loop of tubes, a racetrack basically, filled with a special fluid called a refrigerant. And this fluid does one job on repeat forever. It picks up heat on one side of the loop and drops it off on the other. Here's how it travels. The refrigerant starts as a gas and enters the compressor, the part responsible for that low hum you've heard your whole life. The compressor squeezes the gas hard, and squeezing a gas does something interesting. It heats it up. Think about a bicycle pump getting warm in your hand. Same principle. Now the refrigerant is a hot, high-pressure gas. That hot gas travels to the coils at the back of the fridge, outside in your kitchen. Here, the gas loses its heat into the room air, cools down, and turns back into a liquid. This is where the heat from your food gets dumped. This is why the back of your fridge is warm. Now it's a cool liquid under pressure. It reaches a tiny, narrow valve, basically a very small hole. The liquid is forced through it. Pressure drops suddenly, and something remarkable happens. The temperature drops with it. The refrigerant becomes extremely cold, colder than anything inside your fridge. That freezing liquid enters the coils inside the fridge, the evaporator, and now the physics takes over on its own. Heat always flows from warm to cold, never the other way. So heat flows out of your food, out of the air, out of that leftover rice from 3 days ago, and into the refrigerant. As it absorbs all that heat, the refrigerant evaporates back into a gas and goes straight back to the compressor. Round and round. Pick up heat inside, dump it outside. Pick up heat inside, dump it outside. Your food isn't getting cold. Heat is leaving your food. There's a difference, and it matters more than it sounds. Here's what I want you to sit with for a moment. Heat naturally moves from hot to cold. That's just the way the universe works. Your coffee gets cold, your ice cream melts. Everything is always moving toward the same temperature as everything around it. But your refrigerator is doing the opposite. It's taking heat from a cold place, inside the fridge, and forcing it into a warm place, your kitchen. It is moving heat uphill, against the natural direction, and that costs something. It costs electricity every single day. The moment you unplug a fridge, heat starts seeping back in from the room. The compressor stops, the loop stops, and within hours, everything inside reaches room temperature, because that's where the universe was trying to get all along. The fridge was just the thing holding it back. And here's something that will feel almost unfair once you hear it. Leaving your fridge door wide open doesn't cool the room down. It makes the room hotter because the compressor is still running, still throwing heat out the back. But now that back heat has nowhere to go except right back in through the open door. Net result, more heat in your kitchen. The laws of physics are not always on your side. Before electric refrigeration, keeping food cold was a full industry. People cut ice from frozen lakes in winter, packed it in sawdust, shipped it across continents, and delivered it to homes in summer. Entire cities depended on it. In 1880, New York City consumed over 1 million tons of ice a year. Then, someone figured out how to make a machine that moves heat uphill using a loop of fluid and a compressor, and that industry vanished in a single generation. The machine that replaced it is humming in your kitchen right now. It has no moving parts except one motor. It uses no ice. It never runs out of anything. It just keeps pushing heat from one side of a loop to the other, quietly, indefinitely. The hum you've been ignoring your whole life? That's a heat pump, fighting physics, so your leftovers survive the night.